Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to discuss another type of factoring. So we already discussed the greatest common factor method, or the GCF method, in our last video, and today we're going to talk about another type of factoring that we can use to factor specifically trinomials. So we're going to focus on trinomials today. We are going to skip the first page. It's just a little game to get you thinking about factors of different numbers, and we're going to look at this trinomial up at the top, x squared plus 5x plus 6. So in our previous lesson, we would have looked for a common factor between all three of these terms. So a common factor between x squared, 5x, and 6. Well, the first thing we probably notice is that not all of them share an x, right? So an x could not be part of our greatest common factor. Then we might think of a number. What's the largest number that they all share? Well, we could put a 1 in front of the x squared, but because 1 is the largest number, the greatest common factor could be no higher than 1, right? It doesn't really help us just factor out a 1 because that's not going to change anything. So there is no good way to use the greatest common factor method here because the greatest common factor of those three terms is 1. So we need another way to factor, and that's what we're going to look at. So take a look at this, these two binomials down here, and just pause the video and multiply those together, simplify, and see what you get. Okay, so I'm going to get x squared plus 2x plus 3x plus 6. And if I simplify, I get x squared plus 5x plus 6. Well, look at that. That looks like the trinomial we saw up above. So this is going to be our goal today. We're going to figure out, how do I go from a trinomial, like what I have up here, how do I factor that into two different binomials, right? And again, we're going to figure out how to do that. We're going to come up with a rigid process for doing that in this lesson. But that's essentially what we're doing. Before I show you, the algorithmic process, the process that you can follow step by step to do this, let's see if you're able to kind of guess your way into these factors. So if we look down here, we have 4 for you to think about, and just see if you can guess as to what should go inside these sets of parentheses. And I will give you a hint. We're going to have x and x, x and x, x and x, and x and x. So you really just have to think about the other numbers that go inside. So pause the video. Maybe you can use the example from above to help you out, but see if you're able to figure out what any of these are. Okay, so I'm not going to walk through how we get these answers. I'm just going to put them up here, and you can kind of check and see if you got any of them right. X plus 6, x plus 2. It's okay if you flip those around. It would still work. Over here we have x plus 5, x plus 1. Down here in pink we have x plus 5, x plus 3. And green on green we have x plus 8 and x plus 3. So maybe you got some of these right. Maybe you didn't get any of them right. The point is, some of these may be easy to figure out. Some of them may be more difficult. Of course, to check and see if you're right, you could always just do your distributing, right? And see if you end up with what we started with. Let's keep going though. Again, we're going to come up with a formal process that you can use every time to arrive at the correct answer. Let's show you one more though. This one may not be as easy as the ones above. So we're still going to have x and x, but let's see if you can kind of guess what number should go next to the x's to make this equal to this trinomial. And again, to check your work, you could always multiply it back out and see if you got it correct. Well, right here, it's actually going to be positive 15 and negative 3. So maybe you're able to get that, maybe you weren't. Again, we're just throwing some examples at you before we show you the step-by-step way. Okay. Now we're going to show you exactly how we're able to figure out those factors. And eventually, you may be able to do it in your head. You may not have to show any work, but probably for the next couple of weeks or the next couple of months, you'll probably need to go through this process just to make sure you're hitting all the steps correctly. Okay. So our goal is to break this trinomial up into a pair or a product of binomial factors. So what we're doing is we're looking for factors of 36 that add to 13. So factors of 36 that add to 13. We already know that it's going to be x and x to start with. Now we just need to figure out, what our other numbers are. Are they positive? Are they negative? And what the actual value of the numbers are. So here's what we do. We make a factor sum chart. And again, we're going to look for factors of 36 that sum to 13. If you guys think about standard form of a trinomial, well, we have ax squared plus bx plus c. Again, and those a, b, and c letters can represent any numbers. So when we make a factor sum chart, we are looking for factors of the constant term, the term that does not have the x attached to it, that sum or add to the b term, the middle term. Okay, so in this case, we're looking for factors of 36 that sum to 13. But if I threw you a new trinomial, well, we're looking for factors of that constant term, the c, that sum to the middle term, the b. Okay, let's think about factors of 36. Well, I've got 36 and 1. But those sum to 37, which is not what we want. Well, I've got 12 and 3. Well, those sum to 15, which is not what I want. I have 6 and 6, but those sum to 12. Well, what is the other pair of factors that I'm missing? I have 9 and 4, and those do sum to 13. So 9 and 4 are the factors I want to use here. So I'm going to get x plus 9. That was poor. Let's try that again. X plus 9 times a quantity x plus 4. That is my factorization for this trinomial. And again, you can check it if you want by multiplying it out. And you would see that you get x squared plus 4x plus 9x plus 36. And if you simplify, you get x squared plus 13x plus 36. This method will work every time if the trinomial is factorable. Now, sometimes you're not going to get any factors that sum to the middle term. And then you would just say your trinomial is not factorable. But if it is, then this method will work every time. Let's do one or two more examples together, and then you'll have some time to practice. We will do the top two. Actually, we'll do the first three. We'll do all three of them. So again, when you're given a problem like this, you're going to have to create your own factor sum chart. So what I do is I just put a little f and s. The f stands for factor, or factors. The s stands for sum. So let's think about it. In this trinomial, what number are we trying to find factors of? Well, that number is going to be 48. We're looking for factors of 48 that add or sum to 14. So now we just want to list as many factors of 48 as we can, in pairs, of course. So I have 12 and 4. I've got 48 and 1. I've got 16 and 3. I've got 2 and 24. And if you want, you can add those together as you go, because you may not need to list all of them if you find the right one. All right, so this will give me 16. This will give me 49. This will give me 19. This will give me 26. So none of the factors that I've come up with have worked yet. But let's think if there's any more. Well, I have factors 6 and 8, and those sum to 14. So my factorization here is going to be x plus 8 times a quantity x plus 6. Now, it's possible that 8 and 6 were the first two factors that you thought of, right? And if so, well, then you're done. You don't have to list all of the factors. You just have to keep listing them until you find the two that work. Let's go over here to the one on the right. Let's draw our factor sum chart. Pause the video. Think about what number you're finding factors of and what those factors need to sum to. Well, we're going to find factors of 16 that sum to negative 10 this time, okay, because that b term is negative. You've got to include the sign. So if we think about it, if we need to find factors of a positive number like 16 that add to negative 10, well, it doesn't make any sense to choose positive factors, right? Because positive plus a positive number is going to give us a positive number, and we need our sum to be negative. However, right, if we come up with two negative factors, well, a negative times a negative gives us a positive, and a negative plus a negative will give us another negative. So we need to think about what the negative factors of 16 are. Well, let's do negative 4 and negative 4. That's going to sum to negative 8. We can do negative 8 and negative 2. And voila, I have negative 10 as my sum. So this time, my factorization is going to be x minus 8 times a quantity x minus 2. And again, it doesn't matter if you switch those, right? I could write this as x minus 2 times a quantity x minus 8. When I'm multiplying, it's going to give me the same thing, right? So both of these answers would be correct as long as you have the right factors. Okay, one more. This one's a little different. So we're going to look at 3x squared plus 24x minus 60. Now, the first thing you may notice is that this x squared has a 3 as its coefficient rather than a 1. All of the ones we've done today have had a 1 in front of the x rather than some other number. So the method that we learned today doesn't work if we have a 3 or any other number other than 1 in front of our first term. So we have to do something first. Well, let's think back to our last video, the GCF method. Do all three of these terms share a common factor other than 1, right? Because 1 isn't very helpful. Well, they don't share any variables. They don't all have an x, so we can't have an x as our greatest common factor. But they do share a 3. 3 is a factor of 3, 3 is a factor of 24, 3 is a factor of negative 60. So the first thing I'm going to do is factor out a 3. And I'm left with just x squared, right? Think about if I divide all of these terms by 3, I get x squared plus 8x minus 20. And now I can go back and use my factor sum chart to factor what's inside. Okay, we're not going to do this problem, so let me just do my factor sum chart over here. I'm going to be looking for factors of negative 20 that sum to positive 8. And if we're finding factors of a negative number, think about the signs of what those factors must be. Should they both be positive, both negative, one of each? What do you think? Well, to get a negative number, I need to multiply a negative by a positive, because a positive times a positive is positive. A negative times a negative is also positive. So my factors need to have different signs. All right, let's just start listing them, and hopefully we get to the right ones shortly. I could do negative 10, positive 2, right? That's going to multiply to negative 20. But that sums to negative 8. Well, I'm pretty close here, right? I need to get positive 8, but I found two factors that sum to negative 8. So what happens if I switch the signs? 10 and negative 2. Well, those multiply to negative 20, and they sum to positive 8. So these are the two factors I want, which means my answer is going to be 3. I can't forget my 3 because I factor that out. 3 times the quantity x plus 10 times the quantity x minus 2. And if you multiplied all three of those factors together, right, the 3 and then the 2 binomials, you would end up getting 3x squared plus 24x minus 60. All right, that is going to wrap this video up. So main idea for today is that if you have a trinomial where the number in front of the x squared, or we could have an m squared or a y squared, etc. But if we have a trinomial, whoops, didn't want to move it. There we go. If I have a trinomial that looks something like ax squared plus bx plus c, where my a is equal to 1, I can use this factor sum chart method to factor. Right? We find the factors of c that sum to b, and then write our factors as the product of two binomials. If that a is greater than 1, like it was over here, well, before I do my factor sum chart, I can try to find a GCF. If I can factor that GCF out, and then I can try to use my factor sum chart. All right, in our next lesson, we will talk about a third and final factoring method that we can use. Until then, have a good day, and we will see you next time.